This is problem number 2 on the sample test problems for test number 1. Consider the function g defined by g of x equals 4 minus x squared. A, evaluate g of the square root of 2. So we plug square root of 2 in for x. Square root of 2 squared is just 2. 4 minus 2 is 2. B, state the domain and range. So in terms of thinking about this function, it would probably help to have a graph. Of course, you could type it in the calculator, but I'd like you to know what 4 minus x squared looks like, or at least I'd like you to be able to figure it out. So basic graph of x squared is this one. Then x squared becomes negative x squared, which flips it over the x-axis. This is negative x squared. And then finally, adding 4 to a function shifts it up 4. So shift this guy up 4, and the red thing is what we're after. And it's worth pointing out that this top point right up here is 4, because we shifted from the origin up 4. So domain and range of G, let's see. Domain is the set of all the x's. Are there any x's that don't make sense? I think the answer is no. Every x is okay in this case. This graph, the red graph, goes forever left and forever right. No holes, no jumps, no nothing. Thinking in terms of the equation, generally domain issues come up when you have division by 0 or square roots of negatives. We've also seen logs. You can't put negatives or 0 into a log function, but we have no problems here. So the domain is all real numbers. The range is a set of all y values. That red graph goes down forever. So it looks like we start at minus infinity in terms of the range. And then we hit all the numbers up until we get to that tippy top point. And the highest number up there that we find for y is 4. And so that range goes up to 4. And is 4 actually in the range? Well, yeah, there's a dot right up there at the top. So 4 is included, so you put the square brackets. Part C, on what intervals is G concave up, concave down? So let's see, this part of the graph, if we were thinking about a cup holding water or not, the water would fall out of that part of the graph. And then if we continue drawing, this part of the graph, the water would continue to fall out. So what that means is that this graph is concave down everywhere. Concave down on all real numbers. Something concave up would look like either a piece like that or a piece like that.